I'm going to do it now. I'm going to record everybody. So do you mind if I record you? Okay, good. Okay, good. So yeah, so let me give you screen sharing. And I'm only recording, of course, when I'm here. You're not being recorded. And again, I'll pass this on to the people that weren't there because I think it'll be useful to them. So I just want to just check in. Any questions about the beginning? I want to go through just briefly how you might start it. Okay, so you have to write 475 both as in this old adic notation and then in the alphabetic notation. And so 4, you would just go up, that's 400, and that would just be 4 100s. So let me annotate. Let me share the screen first. Okay, and you're seeing that sheet, right? Okay. So here we got 475, and so 400 would just be h repeated 4 times. And then 70, for 70, I would go like 50 here. And they all look alike, but it's in the middle and it's touching. So I think of that, I don't know, as a hangman's gallows or something. And then the 2 10s would be the deltas. Does that make sense what I'm doing? Yeah.
Yeah.
So just to do those in both systems, just to give you a feel for how they wrote. And then I think that'll go quickly once you get the hang of it. And this one, it's weird. You're supposed to, from all these clues, figure out how long he lived. And it's the way that I thought about this is think of it as a timeline. Here's sorry.
And then we can chunk it up into different sections.
Right. And then you're going to end up with a first degree equation, which is going to reduce to something like this. Okay. And it's just a little confusing and can take some time to get to that point. So I'll start you off. So like his boyhood was 16x. And we're trying to sort of construct how long he lived. And then after another 1/12, so let's say he lived to 60, he started growing a beard when he was 10, okay? And then for the next 5 years, you know, he started growing a beard when he was 15, okay? So then that would be how old he was when he started growing a beard. And then he got married after another 1/7 of his life. So at this point, he's married. That would be his marriage. And then so forth. You go on from that. And you'll get a long equation with x's in it. And what you're going to do is you're going to end up over here with how long he lived. And so all these clues here will be an equation on this side. Mm-hmm. Okay. So it's kind of a fun equation. And you're figuring out how long he lived. And so like I don't know if anybody knows, and this, if you see, this came, this thing, it doesn't, it does, yeah, it's from the 10th century, so it's, our first source of this is like 800 years, 700 years after he died. So who knows how accurate it is. And, you know, I like to think that he made this up on his deathbed. You know, his grandchildren said, "How old are you?" And he goes, "This is how old I am," and did it and then croaked. So I don't know, but okay. So I think that gives you enough to get started. And then we'll see where you are. Start looking at the let me know when you get through that. How about that? You can just send out that message. Okay. Questions before I go? Okay, sounds good.
Oh, so you want us to let you know when we finish figuring out how old he was?
Yeah.
Okay.
Okay, thanks. Okay, see you in a bit.
Okay.
Okay, you should be able to share documents now. I'm going to share the handout. And hopefully you're seeing the handout.
Yeah, we are.
Okay, good. So we're probably going to end up skipping the third section. So for the first section, I don't know if you had a chance to read it and make any sense of it.
I understand the alphabetic notation. I don't
Right.
really understand the adic notation.
Okay, so let's go through that. So 475. Oh, let me turn on the annotation. So we want to write 475. So 400, I would go to 100 and write 8. It's like Roman numerals in a way. So
I write 4 H's.
Yeah.
Okay.
Okay. And then for 70, you could write 7 deltas, but to me it makes more sense to use the 50 over here.
Mm-hmm.
And so whatever, it looks like a hangman thing or something like that, like in the game. And then you would write 2 tens. And then you would go and see 5. You have a 5 over here somewhere. Oh, here's the 5 right here. And then you would just do, and then that is the symbol for 1. They didn't say anything about that in the table for some reason, but that's what 1 is. Does that help?
Yeah, that makes a lot of sense. I didn't know how it just kind of gave us these numbers, and I didn't know how
Yeah.
you put them together.
Yeah. And then this would be something similar. And then it's not essential. I think this is a good one to do. Diophantus, it's like, I like to think of it, he was dying and somebody asked him how old he was. And so he gave them this riddle and then kind of just, left the earth. You have to think of this as a timeline. All these clues are going to give you a way to add up how old he is. And over here, you'll have, on the left-hand side of the equation, you'll have his age. And you're going to end up with a nice linear equation, something like that, something of this form, when you're all said and done. So there's no higher order things. So, okay, let's just say X is 60. I'm not saying it is. Let's just say it was. That would be 10 years of his life. He was a boyhood, and then he grew his beard after another 1/12 years. So he would have been 15. So this would be the period. So these added together are how old he was when he grew his beard.
Okay.
And then he got married another 1/7 of his life after that. So 1/7 of his life passed, and then he got married. And so you can construct a whole thing from these clues. You can construct a left side of the equation. So it's going to be equal to X.
Okay.
Okay. And then let me know when you're done with that. I'm pretty sure we're going to skip 3, so we can start 4.
Okay.
Okay. Does that sound good?
Yeah.
Okay. So do you have questions about anything?
Not at the moment. No, I don't think so.
Okay. Okay, great. Thanks, Colin. Okay.
Yep.
So I'll see you in a bit.
Sounds good.
Now we can use the alphabetical one.
Okay.
Oh, hi,
Okay.
sir.
Yes. So let's see. So I'm looking at 1. 47. Where's 470? It looks like you started writing 475, right?
Yep, at the 1.
Using
Oh.
minuses?
We have no idea how they write it. So.
No, you had the right idea. So like it's like Roman numerals. Like, so for 400, and I know I'm late getting to your I went to get the other group started first. So 400 would just be 4 H's.
Oh, that makes more sense.
Right. And so you had the right idea. I mean,
Oh, okay.
and then you have everything else pretty much. And that's the 500. I mean, I'd accept that. Why not, right? Except M is 10,000.
Yeah, 10,000 minus
Yeah.
262.
Right, but yeah, and they just put them next to one another. So that would be an X there. Oh wait, you're doing number 2. Sorry.
Oh yeah, that's number. Yeah, that's not number 2. That's 9,738.
Yeah.
Yeah,
And then-
number 2 is is the first one.
Got it.
On the paper.
Yeah, so you got the idea. And then this is easier, right? The second one?
Yeah, the second one is just
Yeah.
copying from the table, basically.
Well, okay, and I want to give you a hint on the second problem is hard to set up, and it always takes me a while, but so I want to show you how to do that, and then I'm going to leave.
Do you mean the riddle one?
No, if you scroll the riddle, yeah, the riddle, yeah.
Okay.
So let me get you started on that, and then you can. Oh, and let me also undo. Oh, you just want to undo your writing. Yeah. Okay. So the way I think of this is you're going to construct an equation whose right-hand side adds up to how long he lived. And so let's say the answer is 60. So for the first, he was 1/6 of his life for 10 years, he was a boy. Okay. And then in 1/12 more, so 1/12 would be another 5 years. 1/12 of 60. Again, 60 is not the answer. So this would be when he grew a beard. Okay. And then he would add another 1/7 of his life, and that's when he got married. And so you keep doing this with the rest of these clues, and you're going to have an equation which adds up to his life. And when you simplify it, it's just going to be an equation that looks like this.
Is that A or?
Yeah, it's just all this stuff is going to add up. You're going to have more stuff here.
I see.
And
Yeah.
that's all going to add up to A, and then that gives you an equation to solve.
Okay.
Okay. You'll have a constant term in here too. So it's just a linear equation, okay, when all is said and done. And now I don't want to give you a hint. Okay. So when you're done with that, we're going to skip number 3. So when you're done with that, let me know, and we'll go. I might introduce number 4, or I might just come to the groups to do it.
All right.
Okay. Does that help?
Yep.
Okay.
Let's see.
Oh, I have this problem I had last time. Here, maybe if I move. I'm trying to get out.
You can just click on the X button with
For
the
me?
drawing
Yeah.
thing. Yeah.
I don't want to close you all out. Oh, well, it's just me. Thank you.
Yeah, it should be just you.
Thanks. Okay, I didn't know that. Yeah. Okay. Bye-bye.
Bye-bye.
Okay. So how you doing?
Pretty good.
Where are you on the sheet?
I just started translating the equations with Diophantus.
Oh, so did you all get in? Did you do it together so you have an answer for number 2?
For the riddle, you mean?
Yeah.
I've got an answer. We haven't checked yet with each other.
Yeah, you should check with each other. How about sorry, Daniel V and Daniel M. Where are you?
I'm still working on it.
Okay.
Yeah, me too. I messed up and I started somewhere else.
Okay. Do you want some hints?
That would be great.
Okay, good. So I'm going to share the screen. I find it hard. It's not that hard mathematically, but just to set up. So are you seeing the screen? Are you seeing the worksheet?
Yeah.
Okay. So, yeah, okay. So I think of making a timeline that's going to add up to his entire life. And it's going to be equal. Since it's equal to his entire life, it's going to be X. So X is how long he lived. And so let's say X is 60. It's not. So the first part of his life would be his boyhood. That's 1/6X. So that would be like 10 years.
Okay.
And then after another 1/12, so after another 5 years, he would have shaved for the first time.
Oh, I see how you're approaching
Right.
this.
Right. and then another 1/7 of his lifespan later. So if he lived to 70, that would be 10 years. But again, that's not the answer. You'd add that. And you're going to use all these clues, and you're going to end up with his whole life. And it's just going to be an equation that looks like something like this. A constant plus an x term. You have to add a bunch of stuff equals x. So it's going to be fairly easy to solve once you get to that point.
Okay.
Okay. I'm going to skip 3. So, and go right into 4. So Eric, if it's up to you, if you want to wait for them to catch up and work on 3. But I want to get into the math.
Yeah.
So let me
Got
know.
a whole number for number 3, so I'm guessing it's probably right because it's pretty easy. I'm guessing to not get a whole number.
Oh, you know what? I'm sorry. I meant section 3. I was confusing.
Oh,
You're still
Yeah.
working on number 3, right? On that number 3. I meant this. Sorry, it's my mistake. I was confusing. Yeah. So when you get done with section 2, the third problem, let me know. And you say you did get a whole number or you didn't?
no, I did.
Yeah. Okay. And you can help them as you want or not, but I'll be back in a minute. I mean, I'll bring everybody back to start the 4th section in a few minutes. Okay. So you all good to go?
Yep.
Okay. Wait a minute. I'm just going to make sure. Yeah, let me do this. And I think I can just send Eric a message. Actually, Eric, you tell me in the private message what it was that you got, what your answer was. And then I'll let you know. I'll just confirm that it's correct. Yep, you got it.
Perfect.
Okay. It's kind of obvious when you think about it when all is said and done. If you think like a teacher, or if you think that okay. See you later.
Yeah.
Yeah.
Hey, question or you're done?
We're done.
Okay. What was your answer?
Oh, 84.
Yeah. And it's retrospect, it's like duh, right? Because 7, 12.
Mm-hmm.
It's a number that all those, it's going to be a whole number. And it's going to have to go into all those things. So, okay. So skip 3, and then I want to get you started on number 4. I don't think it's that hard. It just takes some. It's more like thinking about it. The math isn't crazy. So I'm going to go to it just to get you started on it.
Okay.
People are in different places, or I would just bring everybody together. So you're seeing.
We've also done the Greek numeration.
Oh, good. That's what I thought. Good. Yeah. So for section 4, you're seeing that on the screen?
Yeah.
Good. Okay. A Diaphantine equation is something that looks like this. It's got 2 unknowns.
Okay.
So it's going to be like an example would be this equation, which is x squared plus y squared equals 16.
Oh, but since we're trying to divide a square into 2 squares,
Yeah.
we have our original size, and then we have 2 different squares, so they're each
Right.
gonna have a different side
Yeah.
length.
And so one of the I would call one of the numbers x and the other one y.
Mm-hmm.
So yeah, and then but the rule for these equations is the solutions have to be rational. And so he's going to come up with a way to solve this that gives you infinitely many solutions. It's going to be a solution that's parameterized by this number k. So try to work through his solution, and then when you're done, what I would suggest is just to go through a few solutions like this, and you're trying to find the solution he got.
Mm-hmm.
And these are going to be functions of k, or x will be, and then y will be a function of x and k. So you're going to end up with some equation that has x's in it. You're going to end up with 2 equations, and you let k equal, let's say 1. That'll give you your value for x.
Mhm.
And then you would plug that into your equation, those two things in your equation for y, and you'd get your y value.
And then you can keep varying k to get different
Exactly.
values.
Whole numbers, so the next k would be 2.
Okay.
It's a real rational whole number kind of thing, because again, they wouldn't have had irrational numbers. And then of course you're going to check by squaring x naught and y naught to make sure
So
they do.
it says given square is 16. So is the area of it 16?
Yeah.
Okay.
Okay.
I just want to make sure.
Right. But not sure he's thinking, I don't know what he was thinking. It's treated as he was thinking about numbers. That's one of the reasons why he's somewhat different from people that came before him, at least that we know about, because he was focusing on algebraic techniques and how to solve equations.
Mhm.
Okay, so that should get you started on that.
Okay. Thank you.
Okay. Oops, did you need to see it again?
No, we have it.
Okay,
So we can
good.
pull it up.
Okay, good. Okay, any questions before I go? Nope, okay, good. I'll see you in a bit. Let me know if you have any.
Will do.
Just checking in to see how you're doing.
Yeah, I think we got 98 or not 98, 84 as an
Yeah.
answer.
And when you think about it, it's obvious, right? Because it's going to be a whole number that 6, 7, and 12 all go into.
Yeah.
Yeah, but until you figure it out, you know. So it's like he made it like a teacher. We wanted to have it come out to be a nice number. Okay. So I'm going to, rather than bring everybody back, I'm going to, first of all, any questions on that question or the one before it?
No, I think we got it.
Okay, good. I am going to skip to the 4th section of the handout. And I just want to introduce it. Okay, and you should be seeing that, the 4th section.
Yep.
Okay. Okay, so I'm going to give you I'll sort of get you started on it. A Diaphantine equation is an equation that has 2 unknowns. And he was like, I think he's dealing with numbers and not geometric objects. And I think he's one of the first that we know of that did. And he's giving tools to solve an equation. So he's trying to solve an equation of this form. And remember, they would have had limited knowledge of irrationals about how to express them numerically. So these solutions are going to be rational numbers. So the goal is to find all solutions. And so and this is the equation you're going to get. He's saying to divide a given square into 2 squares. So the given square, he says, is 16. And then x is going to be one of the squares, x squared. And then the second is going to be y squared. So you want the square of 16 to be equal to 2 smaller squares. Okay. And so he's going to go through a way to solve it. And you're going to end up with having x as a function of this k. And he's going to define the k here. Or actually, he defines it up here. And then you're going to see that y is going to be a function of x and k. There's a couple of things in here that are tricky. Okay. And so what you want to do is you want to generate solutions. So the way I think about it is you're going to have 2 different equations. You're going to have one equation here and one here. And so the way that I think about it is that, sorry, this k should be on top. Is that we'll have the value of k here, and we'll have a formula for x and y. You let k equals 1, then this is going to give you a value for x. You just plug it in here. And then to find y, and you get that. Okay. Now to find y, you'd plug x equal into 1 and then x naught. Sorry, I got distracted by something going on here. To find y, you'd plug x into y, the x value that you got, and use that same k value. And that'll give you a y value. And then if you square those two, you should get 16. So, and what this is, this tells you how to set up these equations here. Okay, so that's kind of the overall throw. Again, the math is going to be just fairly straightforward, but it's a little bit, might be tricky in a spot or two.
Okay.
And you'll end up with a nice equation for x in terms of k. Okay, so hopefully that'll help get you started. And you can let me know if you have any questions as you're working on it. Okay, so before, does that help at all?
Yeah, I think that'll help us.
Yeah, it gives you some context. Okay, good. So I'm going to stop the share unless you want to look at it a little bit more. And let me know when you get questions. Like when you get to solving this equation for x, you'll have an x squared term, but it will be in every term so you can factor out an x. Like these, you'll see, and then just make sure you factor out the x, and then you should be all set. Okay, I'll let you go. Any questions before I leave? Okay. See you in a bit. Oh, okay. Yeah, I'm in everybody's in breakouts, and I just was going to come out and ask you what it was. Okay, good. Okay, so I'm going to go into another room. Let's see.
Times 9.
Hi, sir.
Hi. Oh, okay. Yeah. You want to start 4 and skip all this? It looks like you got it right though.
We already finished number 3,
Yep.
so the answer is 84.
And when you think about it, it's an obvious answer, right? Because he has a 6, a 12, and a 7. And you know it's going to work out just right, like to a nice number.
Oh,
Yeah.
at first we were kind of skeptical, but we Google searched it, so yeah.
Yeah. It's a fun question, yeah. Okay. So let's go on to, I want to get you started in number 4. If you want to scroll to number 4, I can get you started.
Is this not number 4?
No, it's section 3. I wasn't clear. I said number and I meant section. And that was my fault.
Oh.
Okay. I mean, you can go back and do that if we have time, but this is, I want to give some context to this problem. Okay. And I'll walk you through it. So it should be okay once you get it done. So here it says to divide a given square into 2 squares. And he says, let the given square be 16. And one of the numbers, let's call it x just so it's easier for us. So he's going to say, well, let 16 equal x squared. That's the first number squared plus the second square. Okay. And he's going to remember back then they did not have a great way to express irrational numbers except as lines. So these solutions are going to be rational. And keep in mind, there's going to be infinitely many solutions. So he gives a solution down here. Oh yeah, right here in part C, he gives a solution. And I'm going to show you how he got those solutions. These kinds of equations where you have 2 unknowns, x and y, are called Diaphantine equations. And they generally we're looking for rational solutions. And they have infinitely many solutions. So the method is a way of coming up with a parameter, which is going to be k, that gives us the solution. So the general idea is that you're going to work through this and you're going to get x as a function of k. And then that's going to allow you to get y as a function of x and k. Notice down here how y is kx minus 4. You'll plug this x that you get here for here. So you're going to get y is going to be a function of x and k. So you're going to have two different equations, one for x and one for y. So you're going to start with values of k. So here's your k, here's your x, and here's your y. So you're going to solve and you're going to get an equation that looks like x is some function of k. It's only going to have k's in it. So you let k is equal to 1. That's going to give you a value for x. And I'm going to call that x naught. Now y, you have to plug in that k. And then you have to plug in what you got for x. And then that'll give you this answer right here. And what's true about these answers is that x squared plus y squared is always going to be 16. So he's giving an algorithm to find infinitely many solutions. Then you would let k is equal to 2, and then let k is equal to 3, until we run out of time. Okay. So again, the math isn't going to be, it's not that bad. When you figure out, you're going to get an equation, and what's going to happen is you're going to be able to cancel out some numbers, and you're going to end up with a quadratic that's in x with no constant term. So it's going to end up something like this, where A and B are going to be more complicated than I'm making it seem. You're going to end up with something like this, maybe. And then what you can do then is just factor out an x. And then you'll end up with something that looks like this. And then you can solve for x. And this will have k's in it. So just keep that in mind, follow the instructions here, and then see where you go from there. So hopefully that'll get you started and point you in the right direction. Okay, and again, I'll come back if you have questions and see how you're doing. But again, this is the equation, and then A, B, and C are telling you how to solve it. And so this is what you're going to end up with at one point. And then maybe substitute it into some other equation that has y in it. You'll get it. Okay. So I'm going to go and talk to one more group, and then I'll be back to check in on you. But questions before I go?
Not really.
Okay, you'll get it. Yeah. Okay. I will see you in a bit.
All right.
Okay. Long time no see, but want to see how you're doing.
I think we all got that problem.
Good. And it's obvious, right? Because it has to be a multiple of 6, 12, and 7.
Yeah.
Right. Yeah. And it's going to be a whole number. Yeah. So did you make any progress in the fourth section? So like the last page, you could skip the third. I'm not really worried about the third page. I mean, it's fun, but we're not going to have time for that.
Skip the third page?
Yeah.
Okay.
And I said it wrong. I said go right to number 4, and I meant go right to section 4. And I apologize for that.
Oh, that's fine.
Yeah. So I'm going to share the screen, and I'll just get you started on this. It's not that bad. You can probably solve it in less time than I'll introduce it. So you're seeing section 4, the page with section 4?
Yeah.
Okay. And it says to divide a given square into, here we go. Divide a given square into 2 squares. And it says, okay, let the given square be 16. And so he's saying let 16 is going to be equal to 2 squares. And he's talking about numbers. This is one of the things that's remarkable about him is I'm pretty convinced he's not talking about geometry here. He's talking about numbers, and he's giving you a way to figure out what the numbers are. Okay. So then he goes here, let one of the numbers be X, let the second one Y. And it says, you know, and then he tells you how to find Y. And it's going to amount to this down here. Okay. So what you're going to do is you're going to follow his instructions, and you're going to end up with an equation for X that's a function of K. So it's going to be one equation, kind of like a parametric equation. And then you're going to have a second function, which is a function of X and K both. And so I'll be more specific, but you're going to find K, that will give you X. Now you have K and X, then you can find K. So what he's looking for are solutions of this form, X and Y. And they're going to be rational numbers. And if you think about it, they did not really know how to express irrationals numerically, but they knew how to express rational numbers, obviously, you know, using the methods that you were working with. So these have to be rational numbers. And there's going to be infinitely many points and so this is an algorithm to find some of them. So he tells you what to do. He tells you how to define the equation for Y. And as you see, it's got X and it's got to have an X and K in it. And then you're going to figure out how to find X, which is just only a function of K. And then the way that you're going to treat this is you're going to let K be equal to first 1 and then 2 and so forth. And then when you have your formula for X, you plug 1 in, you plug K in, K equals 1 in that formula for X, you're going to get a value for X. Now you have your X and you have your K. And so you're going to plug these in and get a value for Y. So it's sequential. You let K be one number, that gives you X, and now you have K and X, and I'm sorry, K and X, and you can get Y. And then you do the same thing for 2, and you'll get a different value. And in each one of these, we're still going to have the original relationship true. So we're generating, you know, infinitely many solutions to these equation with 2 variables. And these kinds of equations are called Diophontine equations. Okay, so that's kind of the procedure. The math isn't that hard. I think you'll figure it out. You're gonna, at one point you might have a quadratic, but every term is going to be a multiple of X. So you'll be able to, you know, you'll have like ax squared plus bx equals 0, and you can just drop the X term. You can factor it out. So you'll see that. So I think it should all work out for you. And that'll be the last thing we do. And then when everybody's done, I'll call you back. So hopefully this will get you started. And again, in terms of finding X and K, you could do it quicker than what I've just explained, but it's hard without the context, I think. But this is his solution method for finding these 2 formulas right here.
This is interesting.
Yeah. Oh, good. I'm glad. I think it's pretty cool too. I wish I knew more about this stuff. And it's Diaphantine equations are a subfield of algebra, and there's books about this stuff. And so he's kind of started this approach to equations as far as we know. Yeah. Okay, I'll let you work on it. And then if you have any questions, let me know. And before I go, is it okay to stop the share?
Yeah.
Okay.
I'm good.
Good. I think you'll get it. There's like 1 or 2 tricky points, but just let me know if you need help.
All right. Thanks.
See you in a bit.
See ya.
Just checking in to see how you all are doing. Any progress?
I'm done with part 4, and I think Emma is too.
Okay.
Yes.
Yeah.
Paige, how about you, and how are you doing? And they can help you. Okay, Nick, you good?
Yeah, I think so.
Okay. Did you get something which looks like, I'm just going to do it on the whiteboard. Did your equation look something like this? I'm doing this from memory, so I may not have it right. I think it is. I think this is what it is. Is this looking familiar? No?
Yeah, you're just missing it's 8K.
Oh, yes,
At the
yes,
top.
yes. Thank you. Yeah, good. You got
You're
it.
testing us.
Yeah, yeah, I'm testing you. That's right. I'm testing myself. Okay. And then, okay, good. And so you got, how many solutions did you generate?
I did the first 4.
Yeah, that's enough. And then if you, I think I put a link to Desmos. If you want to go to that, I just kind of graphed it out. It's up to you, or you can explore. Do you think, let's look at question number 4 there. Do you think this will work for other numbers? Like if we didn't have a 16, is there anything special about that 16? And what would you have to do to adjust?
Is it
for
because
that?
it's the square of a square?
Oh, I don't think so.
Okay. Well, we'd have to change our y equation, wouldn't we? Because that 4 is because that's the side length, isn't it?
Yeah. Yeah. Well, again, where does that 4 come? The square root of what?
16.
Right. So what would be the next number to try for c squared, for c? We had 4 squared. What would be the next logical one to try?
5 squared.
Yeah. And see if that's, one of the questions, and I'm going to ask something about this for homework, for handing in at some point, but, see, that's one of the questions I have, whether that will work. And I'm not going to answer that. You can work it out. But again, if you want to go to the Desmos link, I did it geometrically, and it's kind of obvious why this works. But think about,
I don't see a Desmos link.
oh. I thought I had one in
Blackboard, yeah.
It's there.
Oh, is it
It's
on
there.
Blackboard?
yeah.
Oh,
It's
my
in
bad. I
Blackboard.
wasn't looking at
That's
Blackboard.
all right. Okay. So I'll let you, I'm going to go to the other groups. It seems like you've got it. And then when everybody's done, I'll just bring everybody back for a quick debriefing.
Okay.
Okay. Sounds good. Glad you got it. Was it tricky at all, or?
I had some trouble figuring out how to get x by itself
Yeah.
at the start.
Yeah. I made it. When I do it, I don't realize the 16s are both positive, and I make it harder than it is. Yeah. Okay. Okay. See you all in a bit.
Okay.
Just checking in to see how you all are doing. Making any progress on that?
Slowly.
Okay. Do you need any, are you stuck anywhere? Do you need any hints? Or you want to keep working? I'm happy to give you a couple of hints to get you over the hump.
I think we got it. I just think we need a little more time.
Okay, good. Okay. Anybody else have a question? Does everybody else agree with that? I'm happy to. Okay. I'm taking that silence as a yes. Okay. So let me know if I'm wrong. Okay. So I'll see you in a bit.
Oh, hi, sir.
Yeah.
Does this look okay to you?
No. I'm looking at. I'm going to give you a hint. Okay.
Okay.
See where it says y is equal to. Plug that in here.
Yeah, we have it here.
I don't think you got to square it.
Oh,
Oh,
okay.
That's what you did. I see now. Yeah.
Can't do algebra.
Me neither. When I did this earlier today, I had 16 on one side and a minus 16 on the other side, and I couldn't figure out what was going on. And then I realized I had this reversed. I had x squared minus 16. So
Nope, can't do that.
no, you got to foil it out. I'll let you figure it out. You can figure it out. Okay. It looks like you're right on track. So I'll be back in a bit.
Thank you. It should be kx squared minus.
Just checking out to see how you're doing.
Pretty good.
Good. Did you get a solution?
Not quite.
Okay. I'm trying to, are you stuck somewhere or you're just working out algebra?
I'm trying to understand the method still.
Okay. Do you want me to help you get through, give you a hint to get you over that?
I think so.
Yeah,
Yeah,
that'd be nice.
I'm happy to, yeah. Okay. I'm going to do the whiteboard. So he said set y equal kx minus 4, right?
Yes.
Okay, he said, and again, he's not telling you why, he's just saying do that.
Yep.
And then
Yep.
you have this here. Agreed?
hmm
So what might you do with that y?
Substitute.
Substitute, yeah. And if you don't make any algebra mistakes, and I did earlier today when I was just messing around with this, and every other group has at some point, if you don't make any algebra mistakes, you'll get something that you can just solve that will look like this. A single power of x equals something over here that just has k's in it. K's in numbers. So try that and see if that helps.
Okay.
Okay.
Yeah, that
And-
makes more sense.
And then one of the, I'm not saying who, so I'm not outing anybody, but one group forgot to FOIL. You know, they didn't FOIL correctly. So,
Ouch.
okay. And for me, when I did it, I had a sign mistake that didn't work. So anyway, so I'll let you work. I think that should get you over the hump.
Okay.
Okay. And then I'm going to give you a couple more minutes and I'm going to call everybody back.
Okay.
But let me know when you get it.
Okay. That sounds
Yep.
good.
Okay. Yeah. Okay. Bye-bye. I think I left you and you were on the verge.
Yeah, are you gonna go over it real quickly with the end of class?
Yeah. I'll tell you what I got. I'll show you what I did because somebody still is on the verge. I want to give them another minute or two. Is that you have y equals 4k minus x.
Yeah.
Okay. And then you have x squared minus y squared, right?
Yes.
So you do that and you're going to square this. And that's all going to be equal to 16. So you're going to have x squared. Sorry, that's y is equal to 4k minus x. Okay, good, right. Okay, so then you FOIL it out and you get 16k squared minus 8k x. No, I'm doing something wrong here. Sorry. What's the formula for y? It's kx minus 4, right? I think I wrote it down wrong. I'm not looking at my sheet. If you look at number 3, he gives it up there. I'll do a share. I'll show you what's going on.
Yeah, it says y equals kx minus 4.
Yeah. And I did it kind of crazy. So let me go back. I should have had, that was my fault. I just was like, I'm not remembering right. Okay. It's been a long day for all of us. Yeah, so y is kx minus 4, right? So I'm just going to double check. Yeah, okay. So you plug that in here. And you, if you, sorry, that's a kx. And you're going to have 16x squared minus 8kx plus 16 equals 16. And so you just cut out that, and this is equal to 0. And notice how you have all x's left. You can divide everything by x, and you get x plus 16x. Sorry, that should be a k. Squared. Kx squared is that. Minus 8k equals 0. So we get this, and now you can just solve for x. And then that'll give you the solution. So then you let k is equal to 1, and you get x is going to be 8 over 2. Y is going to be at k times x minus 4, which is 0. So that's the first solution that you get. Then you let k is equal to 2, and x is going to be 16 over 5. And what's y going to be? You can go to this equation here. Y is going to be equal to 2 times 16 over 5 minus 4. And that's going to reduce to 12/5. And that's the solution that he got. So if we let y equals 3, you get another solution and so forth. Does that help?
Yeah.
Yeah, yeah. So I'm going to call everybody back. I think most people were about where you were, and I think or a little bit further. So I'm just going to recap really, really quickly. Probably won't do much at all, because I don't want to keep people. Okay.
Were you still gonna call us back to the main room, Dr. Alexander?
Oh, I thought I just did. Oh, no, I didn't. Okay. Yeah, I'm going to say goodbye. I'm going to show you the solution and then say goodbye.
Okay. I was having trouble getting the x squared out of there.
Uh-huh.
Yeah, that's where I got stuck.
Okay. You should have a power of x everywhere. There should be something like this: x squared plus k squared equals, I'm sorry, k squared x equal 8kx. And then you can just factor an x out of everything. So something like that.
I see.
Yeah, okay. Sorry, I know I'm rushing this because it's late and I realize that. So I just want to show you, I think everybody had it, but I just want to I'm just going to wrap it up super quickly. I'm not going to go through any math. For X, I got 8K over K squared plus 1. And then for Y, I got Kx minus 4 because that was given. And then if you just plug in values of 1, you're going to get X is going to be equal to 4. Y will be 0. When you do 2, you're going to get 16/5 here when you go through that math. And over here, you're going to get 12/5. And then you can keep going with that. Okay. So hopefully, did everybody get that? Or got it? Okay, good. If you got it, feel free to go. If you have any questions, I'll stick around and make sure that you got it if you want. And then also I can encourage you to, when you're following up and doing your, your work outside of class, is to go to it's going to turn out that the solution looks like this, a circle and a line. And I made a demo of that at Desmos. So I don't want to keep you any more than I have, but if you have any questions, stick around.
Have a good weekend, Dr. Alexander.
You too. Thank you, Daniel. Yep. Or was that Colin?
That was Daniel.
Okay. I thought so. Yeah.
See ya.
Okay. I'll see you. Yeah, bye-bye.
Dr. Alexander, have a nice weekend.
Yes, you too, Daniel. Yep. Did you have a question, Colin, or?
No, I got it.
You got it? Okay, good. Okay, I just thought you were still here. I didn't know if you were hanging around to ask a question. Okay. Well, have a good weekend.
Thank you. You too.
You're welcome. Yeah, bye-bye.